So in this video, I'm going to talk about system programming and error handling. We're going to discuss Errno and understand error handling strategies for system programming in Linux. So the C library mechanism for reporting errors is Errno, and the functions that are associated with it and the Errno access is handled through errno.h. So what you'll see in a lot of the API functions that we'll discuss and use this semester that are based on POSIX are statements like this in the return value talking about how errors are handled. So in this case, for the fopen function, if there's an error that occurs, null is returned and Errno is set to indicate the error. So there's a list of POSIX defined errors, and one error that you might get, for instance, with the file open command would be enoent, which means no such file or directory. So this is what you'd get back from fopen if you tried to open a file that didn't exist. If you want to try to map those to specific error numbers, values that would show up in the Errno value, you can use Errno-L, and you can see that enoent is represented by number 2 in Errno. So here's an example of a really simple program that tries to open a non-existent file. So we have a file name of non-existent file.txt. We try to open it with fopen, and we then print, if the file returns null, we print out some information about the error using access to the Errno variable and using the perr function that references the Errno variable. So here's an example of what you see when you run this. The value of the Errno is in fact 2, and the perr response is no such file or directory. And you see we have two different ways to return that string. One is to call perrno directly, and a second is to call stirError with the Errno variable. So this perr is a function that's described for us that's going to print to standard out a message describing the Errno, the underlying error described by Errno. So one thing to think about, though, when you're using Errno and error handling code is that the value of Errno is possibly modified as a side effect by some of the API functions that you call. So for instance, if you look up fprintf, you'll see that in some cases fprintf may set Errno. So what does that mean? It means that there's a chance that Errno could change between the time you call, between the time the error happens here in fopen and the time it's actually printed through fprintf or perr. So how would we handle this? You could move the fprintf after perr. You could also save Errno to a local var. So that's something that is probably a good thing to do if you're going to be referencing the Errno in multiple places. So given what we just talked about threads and threads sharing memory space, you might say, well, wouldn't there be a problem if Errno was set by one thread and then an error happened in a second thread? Wouldn't the second thread override the Errno that happened in the first thread? And normally, if we were just using a global, that would be the case. However, the POSIX standard specifies that Errno is more than just a global. It's actually using what's called thread local storage. So you're guaranteed to have a separate copy of Errno that's valid for every thread that you're using and will only be set by the current thread you're running in.